Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we finished up our CPU summer and we're rolling on into fall. Football season, one of my favorite times of year. We've got a great new topic for you today, and here it is. Introducing the Micro I/O Relay Module. This is a new product, a brand new product that we just hinted at with a single slide towards the end of our CPU 300 launch webinar we held a couple of weeks ago. And if you haven't checked that out yet, it is available on our YouTube channel. Just check out that replay. But today, we don't just have a single slide with a little bit of information on this new product. We've got a lot of information on this new product, including lots of demonstrations. So without further ado, let's break down today's topic. We're going to start by answering the question, what is the Micro I/O Relay Module? What's it all about? When would I use it? We'll go through the specifications. We'll show you how to wire it up. We'll go through the configuration in Cscape and what version of Cscape that you need to use it. And there will be plenty of demonstrations. Here we go. Okay, so what is this new Micro I/O Relay Module? Well, it's a new compact 8-point relay module that's been designed to expand the capabilities of the Micro OCS entry-level all-in-one controller line. Now, because it is tied to the Micro OCS, at least from a design goal standpoint, it has been designed to be extremely economical and easy to connect. Although, keep in mind, we'll cover this later, you can actually use this product with any Horner OCS line. Now, we have two models available. We have one model that's expandable. In other words, you can add multiple modules to a system. And we have another model that's non-expandable. In other words, if you only need a few relays, less than 8, and you want to add them quickly and in the most economical way possible, you can use the non-expandable model. That's called a -A. Okay, so why would you use the Micro I/O Relay Module? Well, I've always been surprised with entry-level applications and how many times that they use relay outputs. I find that with, mid-size applications and high-end applications, they tend to use more solid state with maybe just a couple relays sprinkled in, whereas with entry-level applications, it's not unusual for them to use relay outputs. So that's why we have a relay output option with the Micro OCS family, but it is limited to only 6 relay outputs built in. So from a functionality standpoint, the Micro I/O Relay Module can greatly expand the number of relays supported by the Micro OCS. That's kind of the first point of its functionality. Also, another thing this module does is it adds relays that support higher voltage and higher current specifications. So that's a big deal as well, or it can be if you're looking for higher voltage and higher current capability with your relays. Also, this module mounts on DIN rail, and a lot of folks really prefer, especially for their higher voltage and higher current signals, for those to be purely mounted and landed, if you will, on DIN rail, so not going through the door hinge. So that's another function that this Micro I/O Relay Module can perform. Now let's go through the specifications. There are 8 relay outputs per module, and they're divided on 2 different commons. That means you could have, if you choose, one voltage level for your first group of commons and another one for your second group. Okay? Your maximum voltage is higher on this product than it is on the Micro OCS built-in relays. It can handle up to 240 volts AC. From a current standpoint, it can support up to 3 amps per relay or up to 5 amps per common. Okay, so those are the limitations. It's got a mechanical life of about 100,000 cycles at that rated load, or quite a bit higher if you're operating the relays at a lower current level. And in terms of how many modules you can add to a system, if you're using the non-expandable version, by definition, it can only support 1. But if you're using the expandable version, you could actually add as many as 16 of these relays to a single system. Okay, now let's take a look at wiring. Now let's start with the I/O wiring there on the left. So as I mentioned earlier, there are 2 commons. You've got your first 4 relay outputs on the first 4 terminals, followed by common number 1. I'm showing DC voltage connected there to the first set of commons. Of course, either common can support either DC or AC. And then of course, after that first common, you've got your second 4 relay output terminals, followed by your second comment. So that's the I/O wiring on the left. Now each module also requires DC power to power it, and that is accessible on the bottom. Okay, so it can support a wide range 10 to 30 volts DC. All right, so that's shown through the bottom connection. And then it also has an RJ45 jack for communications back to the Micro OCS that's also on the bottom. So we'll cover that next. Okay, so if you're wiring one of these modules, let's talk about the non-expandable one first. If you're wiring this one to the Micro OCS, it simply connects with a standard RJ45 patch cable. Now it's not using Ethernet, but it is using Ethernet style cabling. Okay, so you simply connect to the RJ45 jack on the back of the Micro OCS, and you connect to the RJ45 input jack on the bottom of the -A relay module. Now, there is no address to set. There's no CAN address to set here. This is CAN-based communications after all, okay? Because the CAN ID on the non-expandable model is fixed at 20 decimal, okay? So no rotary switches or anything else to set. All right, and you just have that one physical connection of the patch cable to make on the bottom of the unit, and it comes pre-terminated. We'll talk about termination here in a minute. Now, if you're using the expandable version, okay, it's very, very similar with a couple of key differences. First of all, it has a rotary switch on the front of the unit that you need to set for its CAN ID. And the legal addresses are 1 to 15. Now, the rotary switch is actually shown in hex from 0 to F, although the only legal addresses are from 1 to F. And if we do our conversion, 1 to F hex is 1 to 15 decimal. The other key difference is there's not just one RJ45 connection on the bottom of the module, there's actually two. There's an in port and an out port. Okay, now, if you're using multiples of the expandable model, here's what that looks like. Okay, so you still connect the first module in the line to your Micro OCS through a standard patch cable, and of course you have to set its address. But then on every subsequent model, you can just connect it through a short patch cable. We sell a 6-inch version to go from the output of the previous module. So you go into the first module from your Micro OCS, and then from out to in, out to in, out to in on every subsequent module that you use. And then at the end, you do require termination, which we're going to review next. Now, why do we need termination? Well, this is a CAN-based communication scheme, even though it uses Ethernet-style patch cables, if you will. And the rule for CAN is always that it has to be terminated on the two physical ends of the network. So at the bottom, we can see there, the bottom left hand, we've got two different diagrams. We're showing a X7 connected to multiple standard modules, and we're showing on the right-hand side an X7 talking to just the single non-expandable -A version. And I've got asterisk placed where the termination needs to be done at the two physical ends of the network. Now, to do termination on the Micro OCS, the easiest way is to turn on software termination. That enables a built-in resistor. So that if the termination is enabled, that built-in resistor gets inserted into the circuit at the appropriate location. And there's two ways to do that. You can turn it on from the system menu or from logic by turning on system register bit 152.4. Now, on the -A model of termination, there is nothing to do because it comes pre-terminated internally on the circuit. It's designed to always be at the end of the network, so nothing to do on the -A model. It includes the termination. On the standard model, which is expandable and has the in and the out ports, you're going to use a physical connector on the very last module if it's on the end. Now, we include that termination plug in the box with the standard expandable model. So you don't have to purchase anything. It's included in the box. Now, what if you're using Canvas or Prime? I've been talking about Micro OCS this entire time, but maybe in your application, you'd like to add, a few relays to a Canvas or a Prime application that otherwise everything else is taken care of by the onboard I/O. Well, don't worry, you can absolutely use this product with those series. You just need a little different cable between your Canvas or Prime unit and that first relay module. And we sell that at Horner. or you can build your own. The ones we sell at Horner go from that CAN double plug open style connector that plugs into Canvas or Prime, and the other end of the cable is RJ45 to plug into the module. And again, we sell those in 3 feet or 9 feet versions, although it's pretty easy to build those yourself if you're so inclined. Okay, now let's talk about Cscape hardware configuration. There's really not much to it. It's really easy to configure, but let's go through the steps. So we're going to start in the hardware configuration area in Cscape. When we're there, we're going to select the CAN 1 IO tab. Okay, once we've done that and pressed OK, of course, we're going to get an option with several tabs showing all the different ways you can add CAN IO to your system. And if you click the Other tab, you'll see the last 2 products listed on the Other tab are these 2 relay modules I'm talking about. The one that's expandable is listed first, that's the DQM803, and the one that's not expandable that has the fixed CAN address is listed next, the 803-A. Once you've selected the one you want and pressed OK, then you're almost done. You need to assign the network ID somewhere between 1 and 15 if you're using the standard model. And of course, you need to make sure that rotary switch on the front of the module matches what you're setting. Now, if you're using the non-expandable version, you'll find the network ID section of this dialog box has been pre-configured for 20 decimal, and is not changeable. That's because that's a fixed address for that module. So once the address is taken care of, then you just need to assign a variable array for your digital outputs to be fired from. Okay, that'll be Boolean variable array. Now, this is a key point. The array is a 16-bit array. Okay, even though there's only 8 relays per module, each module is assigned 16 bits. Okay, that's just the way that the IO expansion system works on the Horner OCS. No less than 16 IO points can be assigned to this style of IO. So remember, a Boolean array dimension of 16. And then you should assign, I think it's mandatory, maybe it's optional, but you definitely should assign a status word, which is a word type variable, and we'll go through that here in a second. Once you've done those steps, hit OK, you're good to go from there. Okay, now let's briefly talk about the status feedback variable. We're going to cover it during our demonstration, so I'm not going to go through every point on this slide. But basically, it's a 16-point integer value where if the lower 8 bits of that value are all zeros, the lower byte is zeros, then you know you're okay. That's really the key point. And then you've got some bits that if they're on indicate some errors. We'll go through those during the demonstration. And you've got a couple other bits that indicate that maybe an error has occurred in the past. And then you've also got a bit you can use to force the OCS to write to this particular module at any given point in time. It'll automatically do it on its own, but if you want to force an extra write, you can do that as well. So all that's done through the status feedback variable. All right, now let's get to our demonstrations and check out these new modules. Let's look at our parts for today's demonstrations. Here is the non-expandable -A relay module. Okay, so we've got our removable terminal strip here with our 10 connections, 4 relays, common 1, 4 more relays, common 2. All right, we've got our LED indication up here. And then this is a removable plug, as you can see, with spring clamp style connections. All right, on the bottom, we just have a single RJ45 input connector, no output connector, and then 3 positions for power. All right, so this is our -A module, non-expandable, one only per system. And then we have our standard module, or our expandable one. The main differences here being the rotary switch, as well as the fact that we have both a input and an output jack. And it also comes with this termination plug, so that if this guy happens to be last on the network, then you add the termination plug. This guy has termination built on the circuit board because he's always the end of the network. All right, so that's the standard or expandable version. And then for today's demonstrations, I'm just using a standard 3-foot RJ45 style, Ethernet style patch cable. This is available from Horner as a 3-foot red cable. And then we have this little 6-inch jumper patch cable. Again, Ethernet style, but this time designed so if you have two modules plugged in next to each other on the DIN rail, you can use this for nice, neat wiring. All right, so that's what we're dealing with parts-wise for today's demonstrations. Now let's take a look at the bench with our non-expandable model in action. So what I have here is I have a standard demo program that is available for you to download if you'd choose. All right, that shows our non-expandable model with the ability to turn relays on and off and the ability to take a look at status. All right, what do the connections look like? Well, for the module, I have a standard patch cable. This is the 3-foot version connected between the back of the Micro OCS on the CAN port and the in port here on the module. And then there's also, you can just kind of see it here, there's also DC connected, 24 volts DC in this case, connected to the module as well. No rotary switches to deal with. It's fixed with an ID of 20. So everything seems to be working just fine. Now, based on the status feedback I'm getting from the module, I've derived an okay situation that says, okay, everything's good, but if there was a problem, I could go to the diagnostic section and take a look at that. But from this particular demo screen, I can turn relays on and off, and when I do that, you can see I get LED indication that shows me those states. All right, so piece of cake. Let's take a quick look at the diagnostics. If I did have an issue, this okay light that I derived would be off, and one of these 3 lights would likely be on. These are the 3 typical errors. If these 2 lights are on, or one of these 2 lights, it just indicates that an error has occurred in the past. It doesn't necessarily mean that it's occurring now, and we have the ability to clear that if we choose, but we don't have to, okay? As long as these LEDs are off, we're gonna have an okay light because we're talking right now. All right, so this is just diagnostic information that you can use that's built into the demo program. All right, so that's a quick look at the bench of the non-expandable version. To make everything work on the bench the way you just saw, we do have a little bit of work to do in Cscape, so let's go through that demo program I just talked about. Let's start in the hardware configuration area on the CAN 1 IO tab, and we can see that we've already added our non-expandable -A model, okay? Now, when I added it initially, I had to hit the Add button here. I had to select Other, and I had to pick this module off the list. Okay, so that's what I did initially when there was no module populated. But since I've already done it, I'll just cancel out there and double-click here to look at how I've configured it. Now, I had no configuration to do on the network ID because this module is fixed with an ID of 20. But I did have to assign a Boolean array to be used as my variable for firing these outputs. And even though this says it's 8 bits, the first 8 bits are indeed the 8 relays, but there's actually 16 bits that have to be available from this array. Okay, so at least 16 bits, not just 8. So I've used the built-in array. There are 4 of them that's built into Cscape that you can choose to use: I, Q, AI, and AQ. I'm using Q for obvious reasons. And because arrays are 0-based, of course, I'm starting on a word boundary. All right, and then I've assigned a micro relay status. That's the name of the variable I've chosen for my 16-bit variable. Now, one more note, you don't have to use these built-in arrays. You can use your own variable array as long as it's a Boolean variable with a dimension of at least 16. All right, and that's really all there is to it. Nothing else needs to be configured. All right, so we're done here from the standpoint of configuration. Now, I did choose, because this is a Micro OCS, I did choose to permanently enable CAN termination because the Micro OCS is on the end. So how did I do that? Well, I created a variable called CAN termination, and if we go take a look at the program variable list under global variables, we can see a CAN termination variable that is mapped to the system register bit SR152.4. So that's the mapping that we needed to do in order for this single rung that turns on that bit permanently in order for that to work. And then the other thing I did was I derived that OK LED that I showed you on the bench by verifying that the status word, at least the lower byte of it, was equal to 0. Okay, and then that causes the OK light to be on. If it's not equal to 0, then that OK light will be off. So that's basically the demo program for the non-expandable module. We're back on the bench, this time with our expandable module, and we have 2 of them, okay, mounted next to each other here on DIN rail. Remember, unlike OCS I/O, which communicates over the backplane, these guys have all their connections here on the underside of the chassis. Okay, so we still have the standard patch cable connected to the input jack on the first module, and then we have our little 6-inch jumper patch cable from the output of the first module to the input of the second. And then we have our termination plug that came with the module plugged into the out of the second module. We did have to set our rotary switches. All right, so I've set the first one to an address of 1 and the second one to an address of 2. Legal addresses are 1 to F in hex or 1 to 15. That's the decimal equivalent of that. All right, and that's really all there is to the connection. So we can turn on and off our relays and we get the indications over here. All right, as you can see. And then of course we also have our OK LEDs and we've got our diagnostics that have been replicated for both modules to the same level as we had with a single module. Okay, so that's really all there is to our bench demo of the standard module. All right, now a quick look at the demo program for the 2 module demonstration, starting again with the hardware configuration, back to the CAN 1 I/O tab. This time you can see we have 2 modules. The first module is configured identically to what I did before, except I had to set the ID here. It's no longer fixed at 20. I set it at 1. That was my choice, anything from 1 to 15. Okay, I still use the same array here, all right, of Q32. And then for the second module, I set the ID to 2, and because we have to have 16 bits assigned to each of the relay modules, even though there's only 8 physical relays, this was now Q48, because we have to be on a word boundary, and we have to allocate 16 per module. Okay, so that's really all there is to the configuration side. And then because we had 2 modules, I had to drive 2 OK LEDs, and I still had the termination that I had to enable in the Micro OCS. All right, now that we've shown you how to use these new products, let me show you this slide that should tell you how to order these products. So the 2 modules, the non-expandable and the expandable version, are shown on the right half of this slide with their part numbers at the top. And then we have all these different patch cable accessories shown on the left-hand side. At the bottom left, I've also shown the part number for the terminator plug, but keep in mind you do get a terminator plug in the box with every standard relay module. The Micro I/O relay module, the standard model, always comes with a terminator plug. But if you want an extra one, or you've lost one, or you just want to buy a few, whatever the case may be, you can buy those from our website or from your local distributor. All right, that does it for our topic for today. We still possibly have some slots left for training, so get on our website and get signed up today if you're still interested in that. And if you'd like to talk to a Horner person about your application, or maybe see some of these new products in action, we're going to be all over the Midwest and the South in the 3rd and 4th quarters of this year, so we'd love to see you at one of these shows. All right, you can interact with us online at hornerautomation.com. We've got literally hundreds of videos on YouTube, just like this one, and we're active on LinkedIn. Now, next week, we have a topic by request from a customer all about analog field calibration. That was a request we had, and we're going to cover this topic. So when would you use analog field calibration? How do you do it? All those sorts of questions will be answered next week. Now, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. All right, so until next week, let's get out there and do some good.